Hi guys, so in this video we're going to be going over radians, which is a very important part of the Add Math course. You won't cover in CIM, but essentially it's important that we just go over it. It's going to be a very quick video, but as long as we know how to do it, we'll be able to use it in future scenarios. So first of all, what are radians? Radians are essentially another unit of measurement. So like we have degrees, we can also have radians. We also do have something called gradients, but we're not going to go into that because we don't need to know it. So it's a unit of measurement, and it's actually quite logical. So the one basis in which you can convert radians to degrees is the fact that pi is equal to 180 degrees. And so that means that pi over 2 is equal to 90 degrees, and 2 pi is equal to 360 degrees. And you might be thinking, well, that's completely random. Like, where did that come from? Well, if you think about a normal circle, let me just draw it here. And then this is the radius. Well, to find the circumference, c is equal to 2 pi r. Now, the circumference of a circle is also hinging on the fact that this is a 360-degree loop. 360 degrees. So you've got a 360-degree loop, and if you multiply that by the radius, you should be able to get the circumference, because it's like this radius scales up this mini circle of 360 degrees. So therefore, we can say it's 360 times the radius. And 360 we can represent by the 2 pi. So because the actual circumference is actually equal to 2 pi r, not 360 times r, we can say that 360 is equal to 2 pi in this case. So really, it's almost as if degrees were derived from radians, and radians were actually the main one we're meant to use. However, personally, I'm very accustomed to using degrees, so I always have to convert it back to degrees, but it's just easier for me to understand because I've used it for longer. So we can also use it for many different other uses, such as area of a sector, length of an arc, trigonometry, and calculus. Let's just go over those. So for the area of a sector, let's say you have a sector like this, and this is, let's say, 45 degrees, and this is radius r. Let's say the radius is 2. So the formula for the area of a sector is theta over 360 pi r squared. So subbing in these values, you would get, well, it's 45 over 360 times pi times the radius squared. So that's 4. And then you can compute that. However, you can use radians to make it even simpler. So we know that 45 is equal to pi over 4. And using the formula half pi r squared, we can get half half theta r squared. That's the formula for the area of a sector with using radians. Half of pi over 4 times 2 squared, so 4, which is equal to pi over 2. And you'll get the same answer as this over here. Now, we can explain why this works. So let's just take a second to write down theta over 360 pi r squared. So this is the degrees formula. Now, if we use our conversion and let pi equal 180 degrees, we get theta over 360 times 180 times r squared, which is equal to, well, the 180 and 360 cancel out. This is 1, this is 2, so you get half theta r squared, which is the radians formula. So that's how that works. So this just means it's a smaller formula, it's easier to work with. So let me just erase that. But the other thing that's also really easy to find using radians, it's actually a much more simple formula, is the length of an arc. And this is actually really, really easy. So if you have this like pizza slice thingy over here, 2 and pi over 4, let's say, because we're going to do radians, well, the length of the arc is equal to theta r. So theta is the angle in radians and r is the radius. So that means it's equal to pi over 4 times 2, which is also equal to pi over 2. So that would be the length of this arc over here. And it's just really helpful in many different circle theorem problems when you need to find the perimeter of a larger object, which we'll come to some practice questions later. Not in this video, but in another one for sure. Then trigonometry, of course, it's used everywhere. Well, trigonometry is literally about angles. You can obviously replace degrees with radians. And when you have a scale like this, you can set it into intervals like pi over 4, pi over 2, pi, etc. And then draw your, I don't know, sine curve or something. So it's definitely usable in trigonometry. And more specifically, the other area in which radians is like necessary to use, and it's not just easier to use in, is calculus. So, for example, in integration problems, let's say you had to integrate the function 1 plus cosine of x. And you were to integrate it, you would get, dx. When you integrate it, you would get x plus, x plus sine x. That's what you get, plus c. Now, when you're substituting values, when you've got a domain, essentially, if you've got, like, let's say, pi over 4 to pi over 2, you could not convert these to degrees because the x over here is not put into a trigonometric value, which means that it won't, like, for example, if you put into sine, you could still put in sine 45 or sine 90. It'll give you the same answer as sine pi over 4 or sine pi over 2. But you cannot put into the x value because the x value does not have a trigonometric value to interpret that angle. And essentially, after what we've just covered with circles and everything, where we know that radians are actually the true value and that you can't just simply replace it with degrees. For example, in the circle, the formula is 2 pi r, not 360r. It's similar in this respect. You can't just substitute 360, which is such a ginormous value, when actually the value is 2 pi, for example, which is much smaller. So in that respect, it is necessary for calculus to use radians. You can't have degrees as your domain because if, for example, if you're integrating cosine of x, it would be completely fine to just use degrees as domain. But if you're doing cosine of x plus 1 that you should integrate, then you would need to start using degrees because otherwise you would be getting much bigger values than required. So I think what I'm trying to say here is that radians are really the main measurements we're always working with. We use degrees because it's easier to understand, but radians are the things that always give us the right answer. So it's important to get accustomed to it. It's obviously normal if you start converting some of the radians to degrees to just try and understand and visualize it better. But it's important that you're able to compute these values in radians because that's the main unit of measurement. Anyway, I hope this video just helped shed some light on radians and where they're used, and we'll go into some practice problems, some of the circle measure questions that you might encounter where radians will be necessary. So thank you for watching the video and hope it was helpful. See you in the next one.